Hello! If you're working to develop your own IoT application, this quick hits video will help get you on your way quickly and efficiently. In this video, we'll create a custom remote tank monitoring solution from the ground up. With the right tools, you'll be able to get this custom application up and running in just a few short minutes. So check this out. Hi, I'm Robert Lutz with Systech Corporation. So you're looking to tackle the job of developing a custom IoT application. For example, you might want to implement a remote tank monitoring system. In this application, you want to remotely monitor one or more tanks that store some type of liquid. These tanks receive liquid sporadically and unpredictably. To prevent them from becoming full, they need to be emptied by a truck that must be dispatched. Also, there are concerns about security at the tank site, such as unauthorized access to the tank contents. The goals of this application include the following. You want to optimize the truck dispatch process, eliminating unnecessary trips. On the other hand, you also want to send the truck early enough to prevent the tank from becoming too full. Also, you want to prevent unauthorized people from accessing the tank. Traditionally, this could take months and months of research and development. You have hardware issues to consider. For example, what sensors to use, what communication technology, should it be hardwired or wireless, how to bridge the data to the cloud. You also have software to deal with, how to collect the data, how to act on the data. Should you perform local data analytics? Can you compress the data to save communication costs? Then you also have cloud software to develop. And what about the user interface? Perhaps a native app for the end user? All this takes time and development resources. Your real goal and a true measure of success is how quickly you can develop and refine your IoT application and convert it from a development project to a revenue-producing application. At Systech Corporation, we're here to help you. We have the hardware and software products and tools to get you into your IoT market quickly and economically. To demonstrate how you can use these tools, we're going to develop a tank monitoring application from the ground up, right here in this single short video. This is real, and I'm not going to do anything behind the scenes. I'll be using readily available hardware that you can typically purchase from multiple sources. I'm going to initialize and set everything up from scratch as if opening these products for the first time. Yet, when this video is complete, it will be a fully functioning tank monitoring IoT application. Since some of this IoT hardware technology is customized, I'll show you how I created the hardware. Typically, these quick hits videos are about 5 minutes long, but since this video will build an entire application from scratch, it'll run a bit longer. I'll be going through the development process quickly, perhaps even fast-forwarding at times. Feel free to pause or slow down the video as desired to see every step. So let's get started. Okay, for this application, we want to monitor the level of a tank, and so as the tank approaches full, a truck can be dispatched to empty the tank. Also, we want to detect if there's unauthorized access to the tank by people that shouldn't be accessing it. So first thing we'll do is we'll use these devices. So the devices for this application are the SL600 for the IoT gateway. We'll use a strobe light for local alerting for some of these activities, a door contact switch for the tampering detection, and we'll use a dial here to represent how full the tank is. So this is a tank sensor essentially. So for this demo, we'll be using a dial to represent how full the tank is. For arming and disarming the tampering detection, we'll use a button to arm and disarm, but this could be really any kind of a arming or disarming solution by a locality of a mobile phone, or it could be via a key switch or any kind of thing. So for this application, we'll just use a wireless button controller for arming and disarming. So first step is we will add these devices to the gateway. So we'll go to the managed, at the moment the gateway shows only one device, which is the gateway itself. So we'll add the additional devices by going into managed devices. And most of these devices are Z-Wave, so we'll select the Z-Wave and add device to add the first device. That puts the gateway into the pairing mode, and we'll take the first device, the door contact switch, and hit the button on the back, which is how you pair Z-Wave devices, and that will be added to the gateway. The gateway is actually reaching out to the device, discovering what kind of device it is, accessing its properties, and then presenting that to the user. Okay, so once that device is added to the user interface, the first thing I'm going to do is change the name to make it something meaningful for the application, and we'll call this door contact for the door contact switch. And then we'll add the second device, add Z-Wave, and we'll go ahead and add the wireless Z-Wave strobe light, again by pressing the button to join that device to the gateway. And once that device is added, we'll rename it for something useful. We'll call that local alert. Okay, and then we'll add the button controller. There is our method for arming and disarming the alarm system. So in this case, I'll press the button on the button controller to add it to the gateway. Okay, so once that is added, I will rename that device to make it more meaningful. We'll call that buttons. And then the final wireless Z-Wave device we'll add is the level sensor. So the level sensor is using, if I open up inside here, it's using a Fortress mini mote, which is sensing the value of the dial. So the add button is here. So I'll put the gateway into the add mode and then press the button within the Fortress mini mote to add that device. All right, now I'll put that back together again. For the real sensor, of course, it could be any kind of device. It could be a Modbus device. It could be a wireless device. Any kind of sensor could be used. I'm just happen to be using this device for this demo. So now I will rename that device as the tank sensor. Okay, so we can look at all the devices. We'll say done on the adding, and I will make these devices look a little more interesting on the user interface so we can see the values. So for the tank sensor, for example, I will map that, and so it's a favorite device, and then also make the general sensor value a value that we can see by making it a key property. We can see it anytime we open it, but by making it a key property, it becomes a value that could be seen here. Now that's a very large number, and we're going to translate that into a more meaningful number in a moment. But first, let me add the door contact switch, make that a favorite, and then make the contact switch a key property so it's displayed on the main screen. All right, so those two key properties are larger, and I guess we could do the same thing for the local alert, make that a favorite, and take its strobe setting and make that the key property so it's displayed. Okay, so for those three devices. Now the tank sensor level is a number that is between 0 and a very large number based on the sensor we're using, the Fortress sensor. We really want to convert that to a number between 0 and 100%, and tank being 0 to 100% full. So to do that, I'll use some coding, and this user interface allows the coding to be inserted right within the scripts itself. So to do this, I'm going to create a new virtual value that's actually going to represent the value, the tank level between 0 and 100%. The sensor is 0 to multiple thousands, but the tank level we want between 0 and 100. So I'm going to create a new value to represent that tank value. So that is a virtual device. A new value is a virtual device. So I'm going to create a virtual device. And there's a variety of virtual devices we can add. In other videos, we've added other things, but we're going to create a real number variable to represent how full that tank is. So I'm going to actually name that variable something interesting for us, which will be tank level. Okay, and that tank level defaults to 0, and that's not going to change because that's just a value that is at 0. So we need to change that based on an algorithm or a formula. So to do that, I am going to take advantage of some coding that I had some help creating, which will actually map the value of the sensor to the actual value, to the percentage of how full that tank is. And so there's a table here that represents those values up to about 3,000, which is a tank level between 0 and 100. And then there's an algorithm that actually does that mapping. So I'm going to insert this code actually right within our script. So I'm going to copy that. And then I am going to go to the scripts and create a script, and we'll just call this tank update, just to update the tank level level. And we will, this is a script that's going to run all the time, so I'm going to trigger on true, so that runs always. And I'm going to have an endless loop, so this tank level is always being updated. So I'm going to say while true, so while forever essentially, we're going to run that code. So I'm going to include Control-C, which is the language we're using, which is very C-like. I'm going to paste that code right into the script here. All right, okay. And we're done with that script. And let's see actually if it works. So I'm going to close this, and this is a script that's in the cloud. I'm going to update the gateway with that code. That's how it compiles the code, it puts it into the gateway, and activate that script. So now if we go back to devices and actually watch what's happening with those devices. So tank level, let's make that larger. We'll make that a favorite. And that's already identified as a key value, so that's perfect. We will shrink that down. All right, and let's see how this works. So we're looking at both the tank sensor, which is that raw value, and the tank level. Now, if I change the value, I'll rotate the value all the way down to 0. Now, this sensor updates once every 10 seconds. So within 10 seconds, we'll see the tank sensor value go down to 0. But actually, it's not going to update once every 10 seconds because the default value is actually updating once every 30 seconds. So actually, while we're here, let's update that. And there's some documentation that comes with the MIMO, the Fortress MIMO Lite device, and there's some Z-Wave parameters. And one of the parameters is how often it sends this value to the Z-Wave controller. By default, it sends it once every 30 seconds. We're going to change that to once every 10 seconds, which is as fast as it can send. So if we look here, parameter number 9, Z-Wave parameter number 9, I simply have to set that value to 1 to program it to update once every 10 seconds. So I'm going to go back to our device. And by the way, it has been 30 seconds, so it did update to a very low value, and the tank level is set to 0. But let's update that so it's updated more often. So to see the programming parameters, I'm going to show all the hidden properties of this device and expose the different properties for the Z-Wave parameters. There we go. So Z-Wave parameter, we're going to change parameter number 9. And we're going to, the size of that parameter is 1 byte, so we'll change that to 1. And we are going to write the value of 1 to that parameter number, which will reprogram that sensor to transmit once every 10 seconds. So I will send that value to the sensor. So now that sensor is going to send an update every 10 seconds instead of once every 30 seconds. So right now we're about halfway. If I change that back down to close to empty, within 10 seconds, we'll see that tank level number go down as well as the tank sensor level go down because those are linked together with the script. And there we go. So that value changed. Okay, so we've done programming the sensors. So let's go ahead and create the scripts to create the alerts required for when the tank reaches too high of a level, over 80%. So let's edit the scripts now. So we go to the script section, where we have our existing script, which is the thing that keeps the tank level up to date. And we'll create a script now that will create an alert when the tank reaches above 80%. So we'll call this script tank full. Not quite full, but we'll call it tank full. In this case, we will trigger on the sensor. So that's a device, and we'll do it on the new tank level virtual sensor, because that's a nice clean number between 0 and 100. So the tank level, the real value of that tank level, if it becomes greater than, let's say, 80%, a value of 80, then we will send a message. So we'll set the, Oh, I don't have a messenger. So let's close that up. Let's save that for a moment. And I need to create a virtual device for the message receiver. So a text message is going to go to a manager to fill up that tank. So let's create that messenger right now. So that's a device. So go back to devices and manage devices. And it's one of the virtual devices. We'll add a virtual device. And one of those virtual devices that we can add is a text messenger. So we'll name that messenger something interesting for us. We'll call it manager. And I'm going to pre-fill in the phone number. You don't have to pre-fill it in, but it could be a programmed value, but I'm going to program it in with my number for the demo. Okay, so that is programmed in and ready to go. So we'll go back to our script. And we're creating that script, editing the script to message somebody if the tank level goes above 80. So we'll add some commands to that. We will set the device of our new manager virtual device, which is the text messenger. We'll set the text message to something useful. Warning, tank almost full. All right, and then we will send that text message. So we go back to the manager device and the send a message property to send. And that should do it for that script. So we have a script that says if the tank approaches full, send a message to send somebody to empty that tank. So I will update that script, compile it, and send it down to the gateway and activate it. Okay, so that script is now activated. We could actually test that value. Let's go look at the devices and see if that script actually works. So right now the tank level is almost 0, but if we raise that tank to almost full, and make sure my phone is on, it is. So once that is detected going above 80, then we'll see if our script executes. So there the script has gone over 80, and yes, the message has gone through that the tank is full. Tank is almost full. So perfect. So that script worked. Okay, now we want to create another script that warns if somebody is tampering with the tank or trying to empty the tank that's not authorized to do so. And to do that, we're going to use the button to arm and disarm the alerting system, and the door contact sensor will be our important thing. So the first thing is we want to be able to arm and disarm the alerting system. So that could be with a key or some sort of a location presence device. For this case, we'll just use the button to represent that. So we need a virtual property that indicates whether the system is armed or disarmed. So I'm going to create another device. So manage devices, another virtual device to manage and maintain status of whether the security system is armed or disarmed. So I'm going to add a virtual device. In this case, it's just a binary variable, true or false, on or off. We'll create that and we'll call that system armed. And then we'll create a couple of scripts to arm and disarm that. So we'll say done with adding that device. We'll go back to the scripts. So we'll create a script to arm the device. We'll call that arm system. And that will be triggered based on one of the buttons on the button device. So select buttons as the device. We'll use button number 1 to arm the system. So if button number 1 is pressed, and it knows that this device can only have the properties of pressed and not pressed. So if the button is pressed, we will set that new virtual property called system armed to true. So the binary value to true. So simple enough. So if the button is pressed, we'll set the system to armed status. So we update the gateway and activate it. Okay, so now we also want to be able to deactivate it. So the same kind of a script, we'll create another script to be able to deactivate it with the other button. So we'll create another script, create a new script. We'll call that disarm system. We'll trigger one of the devices, the button device. We'll trigger on button number 2 this time. If that button is pressed, then we will set the virtual variable of the system armed the binary value of that to false. So if button 2 is pressed, turn off the system. We'll compile that, send it to the gateway, and activate it. All right, we should be able to see that up and running and active. So let's look at the devices. We'll see our new virtual device called System Armed. There it is. In fact, we will make it a favorite, so it will appear right there. All right, so the System Armed is false. So if I press button number 2, button number 1. So if I press button number 1, then the system becomes armed. Then if to disarm the system, if I press button number 2, that will disarm the system. So that is working fine. And again, that could be a key or other kind of a solution to actually arm and disarm the system. Now we'll create the script to send the alert if tampering is occurring. So let's go back to scripts, create another script. We'll call this tamper detection. In this case, we want to trigger on 2 things. If the door is being opened while the system is still armed. So we'll trigger on one device, which is the door contact. If the door contact switch is open, and knows open and close are only valid values, and, put an and in here, and our virtual device called System Armed binary value is true. So if that occurs, what do we want to do? We want to turn on the strobe light, the local strobe light or alarm or siren, and we want to send a message. So we'll set the local alert, which is the strobe light, the strobe setting to strobe. We could also turn on the siren if necessary. And we want to send a message to the manager. So we'll set up the correct message, the text message. We'll say warning, tampering detected. And then we'll send that message. So set the manager, the send message property to send. So if tampering is detected, turn on the local strobe light and send a message. So we'll compile that script, send it to the gateway, and activate it. All right, so now we'll see that in action. We'll see if it works. We'll go back to the details, I'm sorry, not details. We'll go back to the devices and see, watch what's going on here. So where's the door? There's the door contact and the local alert right there. Okay, so right now the system is not armed. So if I were to open the door right now, we could see the door contact is open, but there's no alerts or alarms because the system's been disarmed and that's fine. The tank is being emptied. Now if we close the door and then we arm the system, in this case by pressing button number 1, if we scroll down, we'll see the system armed is true. Now, if we were to open the door, the local strobe light and siren sends off, and now I've just received a text message that says warning, tampering detected. So we're able to complete the application. We've added the devices such as the local strobe device, the contact switch, the arming and disarming solution, and done all of the programming and scripting within the gateway. So the application is complete and performs its function, giving the alerts when our tank is becoming full and when tampering occurs by unauthorized personnel. This is just one of many Quick Hits topics available at Systech.com. Take a look at other Quick Hits Fit topics, and I'm sure you'll see one that you'll find valuable. For more information, check out IoT hardware and software solutions available from Systech Corporation. And leave a note there if you have ideas for future Quick Hits videos. Thanks, and have a great day.